Inscribed, this is on page 43. Inscribed, it tells us that we're going to have shapes formed inside. Okay, and it's the questions that have diagonals in them. Okay, and I will talk about the most common ones. So the color I'm going to use for diagonals, I want you to remember diagonals do not go to the center. Okay, I will say that they do not connect to the center like we have been seeing. I will just show you. Sometimes students confuse, oh, these are diagonals, because we kind of spent a bit more time now on diagonals. These ones go to the center and they're not diagonal lines. Okay, let's go here and just say, for example, we've got this pentagon here. So let's count first. 1, 2, 3, 4, 5, right? N is equal to 5. It's a pentagon. And I know this seems basic. It's like I know how to count, Mr. Dirksen. I know that. But that's what you want to start with. And then you want to focus in on that diagonal that has been added to this. Okay? And so it creates two different shapes. It creates one here. That would be a quadrilateral, right? A four-sided shape. In particular, it's a trapezoid. I don't know if have you ever heard of that shape, a trapezoid? Some classes have desks that look like trapezoids, right? And then the next one is the top here, which is a triangle. Okay. So you've got a triangle and you've got a quadrilateral underneath. Next, you've got, let's look at how many sides this has first and foremost. 1, 2, 3, 4, 5, 6, 7. This is a n is equal to 7. It's a heptagon. You've got that diagonal appearing again, and you've got two different shapes there. Which one have we already encountered before? The quadrilateral here happens again up here. I'm going to use the same color that I used for that. This is my quad, right? And now there's a new one appearing, which is this one. What is this one? How many sides does that one have, including the diagonal, including the green? 5. So this is, can I call this a pentagon? Yes. It's not a regular pentagon, but it is a pentagon. So this is what I want you to remember. The diagonal, you don't focus on that right away. You first focus on the outside, count how many you have, right? Same here, there was a 5-sided, a pentagon on the outside, and then you focus in on the smaller ones that result from it, okay? So these are all isosceles shapes. So for example, if we take out that triangle, right? If we take that one out, right? The roof is the outside of the pentagon, and this is my diagonal. Why is this one called I? This is the interior angle of which shape originally? If we go back to the original, it's the interior angle of the triangle, but ultimately the pentagon, right? It's the pentagon. That's where that I comes from originally. So we want to find the interior angle of the pentagon to get this. And how would we get these base angles here? It being an isosceles. Here it is. This is study sheet entry, okay? we will go 180 minus 2 times b, sorry, I need coffee. I almost got it there. 180, because it's a triangle, minus the interior angle that I can easily find. All of that divided by what? 2, yes. And that is how you would find that angle right there. They're actually the measure of both of these. Before I continue, I want you to make sure, what is it? Why am I doing this? Because sometimes the question will ask you for that angle right there. And some students jump right into the triangle. And I will say, hold it, zoom out, focus on the big shape first. Figure out this angle right here, which is based on the pentagon, right? Then you zoom in. Now that you have that, you can find either one of these. They will both be the same, by the way. Right? It doesn't matter. They'll both be the same. When you do this calculation, you'll find out the measure of each one of them. Okay?
Excuse me.
Yes?
They both are not different diagrams.
This is supposed to be the triangle from up here.
Oh, they are same.
They're the same. Okay, next, I'm going to take this trapezoid out. So if you have that color, I'm going to try to zoom out for this journey, okay? That trapezoid, if I were to take that out and work with it, have you ever heard of an isosceles trapezoid? But there are isosceles shapes that are not just triangles, okay? Where are there? Go ahead. This one is, unfortunately, this one I already, while I transported it over, I flipped it, I turned it, and I made sure that these angles are down here, and these are the interior angles, okay? But there's an interior angle there, and an interior angle there, okay? Those are the two eyes here from the pentagon. Question, will it always be from the pentagon? No, because look, we had one here. The interior angles here are ultimately from the heptagon, right? So you have to watch out. But to find these angles down here, you would go, what's the sum of all angles in this one? 360. Minus, how many eyes are there? How many interior angles of the original shape? 2 eyes. Make sure you put that in brackets. I'm going to zoom in here. And we divide it by 2. Yeah, because we take this away from 360, and whatever remains, we're splitting them equally amongst the 2 angles that remain. So this is how, on your study sheet, if you have an isosceles trapezoid, this is the formula you would use. If you have an isosceles triangle, this is the formula you would use. And I forgot something on the first one. It's implied, but some students miss it. There should be brackets around the top expression, because this needs to happen first before you divide by 2, okay? Can you guess what the formula, I wonder if you could, some of you could probably come up with the formula for that last one, the pentagon. This one here. I used blue up there, right? So maybe I should stick with the plan here, right? This is technically the blue part that I highlighted up there, whatever you used for your pentagon up there. And same for the trapezoid and for this pentagon, I used green for the diagonals, right? And I think I had pink for my trapezoids. It's probably a good idea when you flip through this, you know where this came from. And I'm not going to do an arrow for this one because it's too busy there. Angle B, these are the same, by the way, because it's an isosceles pentagon. What do you think it's going to start with? 540. Minus. How many i's? 3 i's. Divided by 2. There we go. There we go. So this is kind of like the next step we're going to take. And I'm just going to make a note here. Angle I in all of these, or you can't see that, can you? A note right there. Angle I is based on the larger polygon they are found in. It's very important that you understand. So don't be finding the interior angle of this, like of a four-sided shape, and put that in here. That'll be wrong. This is based on the original larger polygon that they were inside in. Okay. Okay. Now, I hope that you make sure these are on your study sheet. Okay. Some students find it beneficial to actually have the diagram attached to the formulas. That's up to you. Make them small. And let's put them to practice now. Okay. Let's put them to the test. Next page, 44. Is that a diagonal, yes or no? Yes. It doesn't go to the center, right, and just stops there. This is definitely a diagonal. I want you to highlight that. And maybe let's write down diagonal, right? But you're not going to zoom in yet. You're going to first stick with what you see, the bigger, larger shape. So let's count. 1, 2, 3, 4, 5, 6. So n is equal to 6. This is a hexagon. And notice that it's asking for B, it's asking for C, it's asking for A. This one you should all recognize. That is the interior angle of that hexagon, right? So let's find A first. That's n minus 2 times 180 over n. A is equal to 120 degrees. I will call this AKA angle I, okay? This one right here is very important. Even if they hadn't asked for it, I would have still calculated it no matter what. Okay. So this diagonal created two shapes, right? This is triangle, and this is what? 1, 2, 3, 4, 5. This is a pentagon. So I'm going to cut this here. And let's find B first there. Angle B. How will we find that one right there? You're like, oh, this is an isosceles triangle. So this would be 180 minus I divided by 2, because it's inscribed. This is the formula Mr. Dirksen gave me. So for now, I'm just going to trust them, I'm not going to question it, right? So B is 180 minus what is I? We happen to know what that is. It's 120. And we divide that by 2. Very careful. First subtract. So that's what? 60. So angle B is 30 degrees. If you're highlighting like I'm doing right now, if you're following, I'm going to use the same color I highlighted the interior angle. I'm just going to make a little dot up there, just letting you know this angle is what I put up there. And if you'd like, maybe even write down this is 120. I figured out what that was. Last but not least is angle C. I'm going to create some space down here. Question. Do you think there's a different way than using my long formula to find angle C here? What do we know about this angle here at this corner? What is it? It's also 120, right? It's an interior angle. So can we just go 120 minus B and figure out C? So I'm going to do that. I'm going to actually show what I'm doing so you're not wondering what happened there. That's 90 degrees. Or you're like, no, I like formulas. I like more complicated formulas. That's what I need. Angle C would be, it's a pentagon, right? How many interior angles does this pentagon have? Like 1, 2, 3, right? It has 3 here. I'm going to actually put a 1, 2, 3. They're all 120 here. 120, 120, 120. So if I use this formula, I'm just going to go back here real quick. If I use this one, I will also find out what angle C is in that case. So let's try it. 540 minus 3 times 120. Make sure you put that in brackets, divided by 2. The top, 540 minus 360, gives us 180, divided by 2. Angle C is equal to 90 degrees. There you have it. So it doesn't matter how you solved it. You still get the same answer. So if you notice a shortcut, by all means, take it. Take it. I'm going to say 44, 45. And I don't assign a whole lot of homework. You notice that? Like, I mean, sometimes you might disagree, but I'd rather you do the few questions I assign than to just give you a bunch of pages and then you're like, you know what, that's too much, I can't do it, I'm not going to do it, right? So some of you are doing your homework, you're doing work outside of class. That is what it takes to succeed in applied. So make sure you keep doing that. Ask me questions, come and see me at lunch. You know the drill.